Hey everyone, and welcome to this explainer. I am so incredibly excited to have you here today because we are jumping right into something absolutely fascinating. We're going to look at the very real limitations of basic AI memory, and then we're going to explore how those limitations are literally being shattered by deploying these autonomous, data detective AI agents into the super complex world of high-stakes finance. If you have ever wondered how AI can move beyond just, generating text to actually untangling massive webs of corporate data, you are in exactly the right place.
Here's the roadmap for what we're covering today. We'll kick things off with the AI knowledge freeze, explore the RAG solution, and then compare Vector versus GraphRAG. After that, we'll decode some Swiss financial data in a real-world case study, and finally, wrap things up with the hybrid AI future.
All right, let's get right into it. Section 1. The AI knowledge freeze.
So, I want you to think about this for a second. What actually happens when an AI's knowledge is completely frozen in time? Because standard large language models, or LLMs, they have a major fundamental limitation. They can only rely on the exact data they were explicitly trained on. They can't natively just go browse the real-time internet, and they definitely cannot access your private proprietary corporate documents. They're essentially isolated in their own little bubble.
And here's where it gets tricky. When an AI is isolated like that, without any connection to external, verified facts, and you ask it a question it doesn't know the answer to, well, it tries to guess. And that guessing from memory leads to what we call hallucinations. This is when the AI generates highly convincing but completely fabricated information. Now, in a casual chat, a hallucination is just kind of annoying, but in enterprise finance, a hallucination can be an absolute disaster.
Which brings us perfectly to Section 2, the RAG solution.
The absolute easiest way to wrap your head around RAG, which, by the way, stands for Retrieval Augmented Generation, is to think of an open book exam. An LLM on its own is basically a student trying to ace a highly complex test purely from memory. But an AI powered by RAG, that is like that exact same student taking an open book exam, armed with a carefully curated stack of verified textbooks and notes right there on the desk. It completely changes the game.
Okay, so how does this actually play out? It's basically a four-step dance. First, you have the user query. Second is retrieval. The system goes out and searches an external verified database for information relevant to that specific question. Third is augmentation. It takes those retrieved facts and literally pastes them into your original prompt to give it context. And fourth, generation. The LLM reads that newly augmented, fact-filled prompt and generates a highly accurate, context-aware answer. It is just a brilliantly simple, elegant solution.
Moving right along to Section 3, Vector versus GraphRAG. Now, this is where things get really interesting, and the fundamental difference here lies in the actual shape of the data. Vector RAG is the most common method today. It takes documents, smashes them into disconnected chunks of text, and sort of floats them in space based on semantic similarity. GraphRAG, though, is an entirely different beast. It uses a knowledge graph where information is organized as an explicit, connected web of entities. Think nodes and edges. It understands not just what things are, but exactly how they connect to each other.
So why does this matter? Well, it boils down to having the right tool for the right job. Vector search is fantastic, and super fast, for unstructured document lookup. We're talking customer chatbots or searching through a giant PDF manual. But if you want to find complex, hidden relationships, like, say, discovering which board member of a newly bankrupt company also happens to sit on the board of a newly formed competitor, you absolutely need the deep, multi-hop precision of GraphRAG. Vector RAG is going to lose that connection in the noise, but GraphRAG, it traverses that exact relationship.
Let's look at a real-world example in Section 4, decoding Swiss financial data.
Over 7,014,137 to be exact. That is the massive number of raw, multilingual records pulled from the Swiss Official Gazette of Commerce over a 7-year period. We're talking company foundations, bankruptcies, liquidations, the whole shebang. The huge challenge here is that crucial details like secondary actors or liquidators are buried deep inside paragraphs of incredibly dense, unstructured legal text. So researchers set out to turn this absolute mountain of text into an interconnected, high-stakes detective board.
To actually manage this beast of a dataset, researchers built a massive Neo4j knowledge graph using this really clever three-phase pipeline. In Phase 1, they pulled out all the explicit corporate metadata, stuff like company names and ID numbers, to create what they called strong nodes. Then, in Phase 2, they unleashed an LLM onto that dense text to hunt down the hidden actors, classifying those as weak nodes. Finally, in Phase 3, they cleaned up all the messy data using strict alphabetical tokenization to merge duplicates into these things called name hubs. That created one beautifully clean, unified identity graph of the entire Swiss economy.
But, having this massive, beautiful graph database is kind of useless if a user can't actually talk to it, right? To solve that, they built a specialized analytical agent. First, it uses a zero-shot intent router to figure out exactly what the user wants, which keeps the AI from getting confused or overloaded with too many tools at once. Then, it uses an agentic reflection loop. This is so cool. It allows the AI to try a search, and if it fails, it can actually self-correct and try another path up to 4 times. Finally, a strict state machine ensures the AI's final answer is properly formatted and actually answers your original question.
So, the million-dollar question. Did this elaborate setup actually work? Oh, absolutely. The results were completely definitive. The research showed that the Agentic GraphRAG system didn't just edge out a standard Vector RAG baseline. It consistently crushed it across literally every meaningful metric. Correctness, relevance, recall, contextual memory, you name it. This proves exactly why the underlying architecture of our AI systems fundamentally matters, especially in enterprise and financial settings.
The performance gap here is just wild, especially in multi-turn conversations. When tasked with holding conversational context across all this complex financial data, like asking a question and then asking a follow-up question based on that first answer, the GraphRAG system hit 76% correctness. The traditional vector baseline, a dismal 34.4%. Vector systems just completely lose the thread of complex relationships, while GraphRAG holds on tight to the context.
Which brings us to our final takeaway in Section 5, the hybrid AI future.
The reality is, going forward, it's not about picking teams and choosing just one method. The future is highly collaborative. The future of RAG is definitely hybrid. We're going to see systems that use the lightning speed and broad scalability of vectors to find initial document sets, and then seamlessly shift gears into deep relationship traversals using knowledge graphs to get those exact pinpoint answers. And what's more, as this research highlighted, we can add modular privacy-preserving layers, like cryptographic hashing. That means even when AI agents are digging through deeply connected webs, sensitive personal information stays totally secure and compliant. It's the best of both worlds.
I'm going to leave you with this provocative thought to chew on. How will autonomous, graph-powered agents change the way we interact with data in the future? We've just seen how they can take 7 million dense legal records and turn them into an interactive, highly accurate detective board. This evolution isn't just a minor upgrade to search. It is going to completely transform everything from auditing public records to uncovering hidden market trends and even stopping complex fraud rings. The data's out there, and now, finally, the AI has the right memory structure to understand it. Thank you so much for joining me for this explainer, and keep learning.